Given a function f of x, we define the inverse function to be the equation that interchanges the x and the y values. So given some x, it'll switch it with its corresponding y value. We use this notation f to the negative 1 power to represent the inverse of the function that we started with. So if we have a function and you put this negative 1 in the exponent, that means it's the inverse of the equation that you start with. Let's examine this idea within a very simple function, f of x is equal to 2x plus 1. So what I'm going to do is compute three values in this function and talk about what the inverse does. So okay, let's start with, we have f of x is equal to 2x plus 1. So this function multiplies by 2 and then it adds 1 to every single value that you put in place of x. So if I start with f of negative 2, if you multiply negative 2 by 2, you get negative 4. And if you add 1, you get negative 3. So we took x equals negative 2, we put it through the function f, and we got negative 3 back. Nice. All right, so what about if I wanted to compute f of 0? What does this function do to 0? If you multiply 0 by 2, you get 0, and if you add 1, you get 1. So we start with 0, we put that number through the function f, and it gave us 1 back. I guess we can do this for the last one here too. What is f of 5? If you double it, you get 10, and you add 1, you get 11. So the function f took 5 and mapped it to 11. The inverse function is just the equation that reverses this process. So if f goes from negative 2 to negative 3, the inverse should take negative 3 back to negative 2. So it just reverses this here. So the way I visualize that is whatever the equation is, if we put negative 3 into the inverse, it should go back to negative 2. The idea of an inverse is to undo what has been done. So like over here, 1 should go back to 0 through the inverse function. And here, 11 should go back to 5. And if I want to use this new notation, here's how I'd write it. F inverse of negative 3, if I put negative 3 into that function, it would give me negative 2 back. For my second example, if I took the number 1 and put that into my function, it would give me 0 back. And likewise, if I put 11 into my inverse, it should give me 5. So the big takeaway is a function takes you one direction, and the inverse would bring you right back to where you start. But the question remains, well, what is this formula? I mean, at this point, I haven't said what that is, but is there some equation that we can figure out that would do this for us? So let's check that out in another example. So how do we come up with this equation that would reverse all of these points, like in the previous example? So what I'm going to do is take my equation and write it as y is equal to 2x plus 1. That's my original function. I'm just calling f of x y. Now, the inverse function is the equation that switches your x's and your y's. So if I call y x and x y, technically this thing is my inverse. It's very abstract looking, but I took my first equation, interchanged all the x's with the y's and vice versa, and I have this brand new equation. It's just not written in a very convenient way. What I'd like to do is now solve this thing for y. And the thing we end up with is actually the equation of my inverse formula. So just to recap, I copied down the same equation that I started with, called the f of x y, and to come up with the inverse, I called this y x, I called this x y, and this technically is the formula that represents the inverse. Our second step is going to be solve for y, get y by itself. So let's pick up there. I have my inverse. I want to solve it for y. Pretty easy to do. I could subtract 1 from both sides. And then I'm going to divide both sides by 2. And here we have x minus 1 over 2 is equal to y. This is the formula of the inverse, so I'm going to write that as f inverse of x is equal to x minus 1 over 2. So f of x was my original equation, and I'm saying that this thing would represent the inverse. I want to verify this by using the numbers we used in the previous example. Like, we saw that f inverse of negative 3 should be equal to negative 2. I want to verify that in this formula that I came up with. That means I'll put negative 3 in place of x, simplify it, and hopefully the answer is negative 2. Let's see. In my formula, f of negative 3 would be negative 3 minus 1 over 2. That means f inverse of negative 3 is negative 4 over 2, and what do you know? F inverse of negative 3 is in fact negative 2. Okay, so that matches up with the previous example. What was the other one? There was f inverse of 1 is equal to 0. Is that true? If I put 1 into this formula, do I get 0 back for the y value? And the answer is, yeah. F inverse of 1 means I put 1 in place of all the x's. And when I simplify this, I get 0 over 2. And that is, in fact, 0. And the last one was, I think, f inverse of 11 should be equal to 5. So if I put 11 into my inverse function, it should take me back to the value of 5. I think that's going to work too. So f inverse of 11 means I put 11 in place of x. 11 minus 1 is 10 over 2, and that in fact does equal 5. So that's nice. I mean, we started with this equation, and the inverse just meant it switches all of the x and the y values. If you look at it in a very abstract way, that means this is the inverse. I call the y(x), the xy, and I solve for y, and the thing I ended up with was the formula for f inverse of x.